Welcome to True Projects. In this video, we are going to explain about the project that is EmoNet, Deep Attentional Recurrent CNN for X formerly Twitter emotion classification. So before getting into the execution, first let us understand what is this project about. Social media. It has completely transformed the way people communicate and share their opinions. Platforms like X, formerly Twitter, allows users from around the world to post thoughts and feelings instantly, generating a vast amount of real-time data. This data provides valuable insights into public sentiments, emerging trends, and pattern of human behavior across areas like politics, marketing, and public health. Emotions here play a major role. That is central role in how people interact and make decisions. So detecting them from social media text has become an important task. Emotion classification, it helps in understanding how people feel about specific topics or events, making it useful for applications such as sentiment analysis, market research, and even decision making support in various domains. So, emotion classification on social media is not an easy task because posts are often short, informal, and unstructured. People use slang, abbreviations, emojis, and expressions that can be ambiguous, which makes understanding the true emotion behind a post quite challenging. Unlike formal text, social media content rarely follows proper grammar or sentence structure, so capturing the context accurately requires more sophisticated techniques. And here, traditional methods like machine learning models that depend on handcrafted features struggle with these complexities and often fail to detect subtle emotional cues. Even deep learning models, which are generally better at understanding patterns in the text, can have trouble balancing the need to capture both sequential context and the local spatial features like engrams or phrase level expressions. This highlights the need for more robust and advanced approaches that can reliably classify emotions in social media posts. So, to overcome with all such issues, the proposed system EmoNet is designed to classify emotions in social media posts using an advanced neural network called Deep Attention Recurrent Convolutional Neural Network, that is DAR-CNN. Social media posts, especially on platforms like X, that is formerly a Twitter, are often short and informal, which makes it difficult for traditional models to accurately capture emotional content. EmoNet tackles this problem by combining attention mechanisms with recurrent and convolutional neural networks, allowing it to focus on the most relevant words while understanding both the sequential and local patterns in the text. And here, the important pattern, that is important thing, is the attention embedder module, which transforms the input text embedding into query, key, and value vectors. So these vectors are then processed using a scale dot product attention mechanism, which allows the model to dynamically focus on the most emotionally significant words or phrases. By doing so, the system can give more importance to contextually relevant tokens, ensuring that subtle emotion cues are not overlooked. Once the attention enhanced representations are obtained, they are passed through three different feature extraction pathways. That is CNN, convolutional neural network. This identifies the local patterns in the text, such as engrams or short phrases that carry emotional meaning. And then LSTM, that is long short term memory. It captures long term dependencies and sequential relationships within the text, helping the model to understand context over the entire post. And the last one is GRU, that is gated recurrent unit. It offers more computationally efficient approach to sequence modeling, maintaining a balance between contextual understanding and reduced complexity. Together, these pathways enable EmoNet to robustly detect nuanced emotions from social media posts. And after passing through the CNN, LSTM, GRU, the pathways, each set the features undergoes, that is, each set of features undergoes global max pooling. So this step helps to extract the most important and relevant features from each pathway, reducing the data to a more manageable and meaningful representation. These pooled features are then combined into a single unified feature vector that captures both the local and long range dependencies in the text. So, this combined representation is further refined through fully connected dense layer with the non-linear activation functions, which help the model to learn complex relationships between features. Finally, a softmax output layer assigns the input text to one of the predefined emotion categories. by integrating attention mechanisms with recurrent and convolutional neural networks. In this way, EmoNet provides a robust, scalable, and highly effective solution for automated emotion detection on social media platforms. And this project has been further enhanced with several key improvements. So, as the extension, we are incorporating LSTM and GRU. First, BERT embedding have been integrated with LSTM and GRU layers, allowing the model to better capture sequential relationships in the text and improve emotion detection accuracy. Second, a new optimizer technique. A new optimizer has been implemented to make model training more efficient and to potentially boost the overall performance. After that, a Flash-based user frontend, that is a Flash-based user interface, has been developed, enabling users to input the text for prediction in a secure environment with user authentication. Finally, topic modeling is used, that is using latent direct allocation, we call it as LDA. So this has been added, allowing the system to extract and analyze topics that are underlying topics in the data set as an additional extension. So these are the things that we have incorporated in the project. Now moving on to the implementation. To implement this project, we have followed these steps which are mentioned in the flow of work. So let's understand how we have implemented the project. So first we have imported all the necessary libraries for data processing, modeling, and deployment. This includes libraries for data manipulation like Pandas, natural language processing, deep learning, PyTorch, visualization, and web development using Flask. Then comes data integration. So the Twitter emotion dataset from Kaggle is loaded into Pandas data frame. This dataset contains social media posts labeled with emotions, providing the foundation for training and evaluating the models. And the next step is data pre-processing, where the raw text data is cleaned and prepared for modeling. And the steps include converting all the text data to lowercase for consistency. Then comes removing HTML tags, URLs, and non-printable characters to reduce noise. And then handling punctuation marks based on the requirements for the model, either removing or retaining it. And then tokenizing the text. So we will be tokenizing the text into individual words or subwords. And then comes encoding labels for classification. So here we will be encoding emotional labels to a numerical format that is suitable for classification. Then comes embedding vectorization. So here contextual embeddings are generated using BERT, which captures semantic relationships and contextual meaning within the text, providing rich representation for the model training. Then comes data visualization. So here in this step, visualizations are created to better understand the dataset, plotting the distribution of different emotion types to identify imbalances, generating word clouds to highlight frequently occurring words and provide textual insights. Then comes feature extraction and data splitting, where relevant features are extracted from the embedding and pre-processed text. The dataset is then split into training and testing sets, ensuring the model can be evaluated on unseen data. Then we will be developing the model for emotion classification. Then we will be evaluating all of the models using accuracy, precision, recall, and FN score. After that comes analyzing confusion matrix. So here confusion matrix are analyzed to understand false positives and negatives. And best performing will be, that is best performing model will be saved for the future use for the prediction. So coming to the part of front end, we have used Flash framework to develop a web interface, which allows users to interact with the system. And their features include uploading the text via front end. So in the web application, users will be able to provide the input that will be pre-processed at the backend. It will be fed to the train model. And then topic modeling will be performed to extract the most relevant words from the input data set. And then the application displays the predicted emotion label along with the confidence scores on the web page. So this is how we have implemented the project. Now moving on to the algorithms used. These are the algorithms used in this project. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. So these are the source code files of the project. Let's understand each of them. In this, we have the data set. So this is the text dataset that is used in this project to train the models for predicting the sentiment emotion. It's loading, just wait for a while, or else let's until then understand the other files. So here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder in which we have CSS, JavaScript, and Bootstrap files. So these are important for visual appeal. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is test case folder in which we have test cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have notebook file, which is an IPYNB Jupyter notebook file. It contains a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells. This is the database file, which is used to store the user information. And this is the topic modeling file, which is the extension of the project for doing topic modeling of the predicted output. And here dataset has been opened. So let's see it. So this is the dataset that we have used in this project. So based on these texts, we will be training the model to predict this label, that is the sentiment. Now close this. And now let's execute it. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space and paste the copied path. Click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. File is being compiled. So this is the address where application has been hosted. So copy this link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So let's paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this project is developed using Flask framework. You can click here sign up, or else you can click here start analyzing. So let's click on start analyzing. You need to create an account first. If you have created, then you can sign in. I have already created, so I'll directly sign in. Click on sign in. Give username and the password. Now click on sign in. We have signed in successfully and redirected to prediction page of the project. So this is the prediction page of the project. So here you can see a text box, right? That is the text box. In this, we are supposed to give the input for predicting. And here you can try with these samples. So let's click on this joy. Here a sample has been generated. Now click on analyze emotion. So this input will be pre-processed at the backend. It will be fed it to the trained model. Then trained model will be giving us the prediction. So here we got the output. Here it has given, this is the input text that which we have given. And here we have the detected outcome as joy. So here, this application predicting the sentiment to be joy. So this text represents happiness, excitement, and positive emotion. And these are the important topics that are key topics for predicting this text to be joy. Now let's try another text. So let's try with the fear one. Click on analyze. So here you can see the given text and it is predicting fear. And these are the topic analysis keywords that are the key topics for this text for predicting to be fear. Now let's try with another text. Click on it. And here, let's give it with some other samples. So let's open test cases. Open test cases. Open sample. So let's apply filter to label. Let's apply filter to class 0. Click on OK. Select a text. Get back to the application. Paste it. And click on Analyze. And here we got the prediction. It has sadness. Let's check with some more. So click on 1. Select this text. Get back to the application. Click on Try another text. Paste the text here. Click on Analyze Emotion. And here we got the prediction test. Joy. It is joy. Now let's try with another test case. So let's apply filter to 2. Let's select this one. Get back. Try another one. Paste the text here. Analyze emotion. So here we got the prediction as love. This is the input we have given, and here we got the prediction as love. Now let's try with the other text. So I've applied filter to class 3, get back to the application, paste it, click on Analyze Emotion. So here we got the prediction to be anger. And these are the key topics. And if you want, you can even share the results also. Let's try with one more text. So get back, apply filter to class 4. Select any text of your choice, paste it, analyze it. And here we got the prediction as fear. Let's try with the last text. Let's select this one, get back, click on Analyze, try another text, paste it here. Now click on Analyze Emotion. And here we got the prediction that it is surprising emotion it is. So in this way, you can do emotional, that is sentiment classification. Now let's check with the graphs. Click on graph. Here the first graph which we have is the sample distribution graph. Here on x-axis we have emotion and on y-axis we have count. So let's close this. And here we have text length distribution graph. This is the text length distribution graph. And here we have word cloud, which shows the most repeated words. Close it. Here we have confusion matrix. This is the confusion matrix. And here we have accuracy comparison graph, where on x-axis we have all the algorithms that we have used, and on y-axis we have accuracy. And here we have precision. So this is the precision score. And here we have recall. And here we have FN score. Close it. So these 4 are the metrics that are used to evaluate the model. Now click on log out. So this project provides an effective solution for detecting emotions from social media text. It delivers accurate predictions, offers clear insights into the results, and allows users to interact with the system easily through a web interface. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.